class yesterday. We did a bunch together, and then I had you do, I think it was 6 and 8. How'd those go? How'd those go? Yeah. 6 or 8. Because it's melting. So the length is getting smaller. Yeah. So let's just, okay, 6, okay. Let me start that. Yes, no. Should I go over it? So, yeah, so try to help me out with, like, where you're getting stuck, I guess. I'll just run through, like, my thought process. Okay, I see a perfect cube. And so right away I'm thinking, well, not yet, I guess. So, okay, I see cube and volume. That's where I start. And then I'm like, because they're always got to give you a shape. So you have a formula, and then you gotta, once you find that formula in that shape, then you, like, gives you, like, an idea where you're headed. So when I see volume cube, like, I just wrote down V equals L cubed right away, because I know that's the volume of a cube, length times width times height, but they're all the same, so it's length times length times length, you know. And then I took the derivative of both, and I didn't even look at the rest of the numbers yet on this one. And then this would be 3L squared times DL dt. I know I'm just writing the same thing. I'm trying to explain to you where I got this stuff. And then I'm looking through, like, what do I know? What do I need to know? I should know every variable in here except for one. If I don't, I got some other ones too. But so, at what rate is the volume changing? Well, that's dV dt. I'm looking for the change of the volume. That's dV dt. So that I can't plug in for. Do I know L? I do. The length is 4. Do I know dl dt? And it tells me the sides are decreasing at a rate of 4, so that's negative 4. And then I've got all my variables except for the 1, so I just multiply. That's the negative word. And then you multiply them out. But I know that makes it seem easy when I just talk through it. So, like, where are you getting? Does that help? If it doesn't, where's the hard part? Okay. So remember that, like, there's the L and then there's the dl dt. So L would be length, dl dt is the change in the length. Or with whatever variable, like R would be radius, dr dt is the change in the radius. You just gotta see, are they giving me the amount or the change? The other, how about 6 I can provide? So for 8, same idea. Like, I see a square, I see area, and I see diagonals. Thanks.
Thank you.
So I need to have a formula that relates the area of a square, that is the area of a square. But I gotta use diagonals. So I can't just go like, oh, it's length squared. So that's how I started. I want to find, like, the shape that I'm supposed to work with in the formula first. And then I take the derivative and plug all the stuff in. Is 8 okay? Go through 8? Don't go through 8. Alright, let's do, the cone ones are harder, and I want to get to those, because you are responsible for them, but I don't want to do it quite yet. I want you to do a couple other ones first. I'm not sure we're quite ready for the cone ones. Let's try 10 and 11. Give those a shot. I'll wait a few minutes, then I'll do them, so you can see, like, my process. And then we'll try the cones. Remember, tomorrow's review, so I made a review for you, so you'll know, what to look for on the test. Test Monday. This is not designed to be a tough test. Like, if you can do the review, you should be, like, totally solid on the real one. The hope is that this can help some of you recover your grade from the last test was rough for a few people. So I'm hoping this one's a little better. Area of the circle is pi r squared. Concerns me that you have to ask me that So, I mean, Quinn kind of already said it. So, when I read through this, I see radius, I see circle, and I see area. So, can you come up with a formula that relates area, circle, and radius? And I would hope that you're starting with area equals pi r squared. That kind of guides your whole. So, then take the derivative, look at what you know, and then plug in. You should be aware of what they are. This is almost always a multiple choice question, so I don't think the units will really matter as far as that goes, but it can help you eliminate some answers if you know what the units are supposed to be. You know what I mean? So for 10, starting off with area equals pi r squared. Do we see why I'm starting with that? So I got circle, radius, and area are the keywords I'm looking at there. And that's the formula that relates all those. So then I'm going to take the derivative of everything. It should be dA dt equals 2 pi r times dr dt. Did you guys notice that? That's kind of cool. So if you take the derivative of area, what do you get? You get circumference. It's kind of cool. So think about how do you integrate a shape? Or how do you integrate a graph? You find the area, right? So if you integrated this shape, this 2 pi r, you get the area of a circle. So it kind of matches up. So then I'm going to look at what I know, what I need to know, whatever. So the radius is decreasing at a rate of 4. What do I plug that in for? The radius is decreasing. Is that r or dr dt? Dr dt, it's negative 4, right? So it's decreasing. The radius is 14. Pi is pi, 2 is 2, and they're asking me what rate is the area changing. So I'm just, I know everything on the right hand side in this one, so there's no like algebra really, just kind of multiplying it out. So whatever negative 8 times 14 is. So negative 112. And then if I'm in area in inches, and it's a rate, what's the label? So first of all, inches are inches squared. Inches squared. Inches would be like if it was just the radius. Area is a two-dimensional thing, so it's inches squared. And then is it inches squared or inches squared per hour? It's per hour because are we dealing with a rate or an amount? We're dealing with a rate, so it's per hour. What's the problem? Everyone's staring at me. What?
Did you just forget to multiply pi, or did you just?
Oh no, I just decided I was gonna. It's Pi Day too, and I forgot pi. So is that what they have? Negative 112 pi?
Okay, I didn't. I got negative 350 something.
So you just multiply the pi into it. That's fine.
Just figure out.
So yeah, if you multiply that out, what did you get, Quinn?
I got negative 351.858.
Do I think that multiple choice on the AP test will probably leave it in pi, but 10 okay? Alright, 11. So again, as I'm reading through, I'm going, okay, I got a cube. I know the length of the sides. And they're asking me about value. So then I need a formula that relates those. So if I have the side of a cube, what? Oh, I didn't screw up yet. I didn't do anything.
It's a cube. Is it always like square? So it's always going to be
Cube is every side is the same, so it's going to be S cubed every time.
So when would it be?
Or
like
L
one
cubed.
times like just like a box?
Length width sometimes is a box.
Okay.
But then
So
any kind of box, like a shoe box is length, width, height, you know. But if I make all the sides the same, then it's length, length, length. You can use length with height and just go, oh, well, they're all the same, so now it's length, 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 which is L, you know what I mean? So the volume of the cube is L cubed. And you can use S. If I use S, it looks like a 5, so I prefer not to. And then dV over dt equals 3L squared times what? Times dl dt or ds dt, if you call it that. Don't forget that part. And then look at what you know, what you want to know. So how fast is the volume increasing? That's dV dt. That's what I'm looking for. The length is 2. And dl dt is this 4 over s. But what's s? 2. So 4 over 2 is 2. 3 times 4 is 12. So is this 24? Alright, what's the label? So it's volume. Are we going to be in meters, meters squared, meters cubed, or meters cubed per minute? Meters cubed per minute, because it's a rate. 11, okay. Those go alright? Okay. Let's go back to like number 1. Number 1 is a little bit tougher. Alright, so I don't want you to start writing it. I just want you to watch what I'm doing. Because it's going to fail at some point. My process that I typically use is going to fail. I want you to see why it fails, then see how we can go back and fix it. So, I mean, I guess you can write it if you want to, but this is not going to work. Like, I'm going to show you a wrong. This is not going to work either. Okay, first of all, we got a cone. And it's being filled with water at a rate of this. So when I see that centimeters cubed per second, what does that tell me I'm working with or looking at? Volume, right? So I've got a cone and volume. So the first thing I'm going to start with is the volume of a cone formula. Does everybody know that? Like, I'm making fun of you if you don't know the area of a circle. But I'll be impressed if you know the volume of a cone. I know you're really concerned about it. Nope. Unimpressed by Google searches. 1/3 power squared inch. So sometimes people like put 1/3. Just a little tip. Sometimes people mess this up and put 1/3 pi r cubed h. But if you had r cubed and h, how many dimensions is that? That's 4. And it's only supposed to be 3, right? So that's kind of a clue, like to keep your powers at 3. But anyway. I'm going to go ahead and take the derivative of this. I'm not even going to get to the error. Alright, so if I took the derivative of this, first of all, what rule would I have to use? Not change. Product. So I'd have to look at it like 1/3 pi r squared, and then h, and do 2d1, 1d2. Okay? If I did that, would there be an r at the end of the problem? After I take the derivative, will there be an r? Yeah, there'll still be an r there, right? Would there be a dr dt? If I take the derivative of an r, will that result in a dr dt? Yes. Will there be a dh here? I'm going to have to do it. So let's do, don't write down. We're going to do product. 2 times d1. So the derivative of this first part will be 2/3 pi r times dr dt. Plus the first thing times the derivative of the second thing. What's the derivative of h? 1, but then to multiply by dH dt. Okay. What's dV dt? Don't write it up. Still don't write it up. Just talk. 9 pi over 4. What's h? 30 and 10 are the size of the actual cone. That's like the best cone I've ever done. We are looking at the water. So the cone is not changing, right? The cone is a fixed thing that we're pouring water into. The water is changing. As we pour water in, the volume's changing, the height changing, the radius is changing. You know what I mean? So as the water fills up, this is getting like more and more full. That's what. So the cone is a fixed thing. So what's the height of the water? 6. 2/3 pi. This is not given to us. We can find it. What's the radius of the water? Use similarity. About 15. So the cone itself 30 centimeters tall and has a radius of 10. What I know about the water part is the height is 6. So what's the radius? 2. So it's just like a similar triangle type 2. So isn't the height 3 times as big as the radius? So when I fill up my water, won't the height still be 3 times as big as the radius? So then I can still look at this and say r equals 2. So then let's go to, okay, what's dr dt? No idea. I don't know. I'm stuck. So this is a blank spot. Over here I can go, okay, r is 2. And dH dt is what I'm looking for, isn't it? So I need to be able to solve for dH dt. But I'm not going to be able to do that because I don't know this. You know what I'm saying? Like if you have 2 unknowns in one equation, you're stuck. So, the way I fix that, well, yeah, go ahead. How can we fix that? Yeah, so the problem is that I don't know dr dt. Right, Livingston? What's the problem? I just said it. I said I don't know dr dt. What's the problem? Yeah, thank you. Okay. Now, if I don't know dr dt, I better not have a dr dt when I get to the part where I'm trying to solve, right? I can't have that there because I don't know it. Well, if I can't have a dr dt, what had there better not be in my original equation? Where does the dr dt come from? It comes from the r. So if I can eliminate the r in the original equation, would that eliminate dr dt from ever existing? It would. So I want to go back to my original equation and rewrite it so there's no longer an r. How do I do that? As the water fills up, doesn't that ratio stay the same? So what's the relationship between h and r? Isn't r 1/3 of h? So this is like, you know how sometimes you have to have the second equation? Now you can start writing. Sorry, I probably should have said that. Do you see what the problem is if there's a dr dt in there? Which means there can't be an r, which backs us up to, okay, we better replace that in the first place. So this is a little tougher than the other ones, but there will be one in your test for sure. So then you have to back all the way up and figure out a way to get rid of r in your original equation. And they're always going to give you a relationship here. And so sometimes they're equal. It'll be 10 and 10. You'd say like r equals h, or r might be half of h, or a fourth of h, or r might be double h. It might be really wide and not very tall. But then once I have that, I can go and say, okay, 1/3 pi, and then r is 1/3 h squared times h. And now this next step for you guys too, because there's fractions involved. What's 1/3 squared if you say 1/6 on the punch? 1/9. And then 1/9 times the 1/3 that's out front would be 127 times pi, and h to what power? Cubed, right? Third power, because I got two of them there and one more there. You with me? What's up? Yeah, where are you not with me? Tell me. I didn't take the derivative yet. No, I don't want to take the derivative of this. That looks like a mess, so I'm making it easier, yeah. Well. Are we okay? Finish it. Well, yeah, let's see. Let's see if you're There are a couple of you, just before I forget, I know you're working, but that asked about some sort of retake on the previous test. And I said I'd think about it, like I don't know what I'm going to do, I don't know what the answer is yet, but I'm going to say wait till after this test, and then we'll look at it again. Because my hope is you do well in this one, and then it's not as big of a concern. Which may or may not happen, but I did not forget about the questions that you asked me if you're one of those people. I'm just waiting for this next test to address it. We get it right? I see somebody starting to check it. You got it? Should I just go through it, or should I wait? Doesn't matter to me. Go. Okay. So here, let me just run through like the whole thing again, because it's going to come up a couple times. I just want to talk through it. So I saw the cone and volume at the beginning, and I started out with my regular process. This is what I would typically do. What's the volume, or what's the formula I'm working with? Take the derivative, plug everything in. It failed because this is the variable that I need to know, so I need all of these other spots to have numbers. I can only have one unknown. And this was impossible to find. Like, I don't know that. So that means this original approach wasn't going to work, and it's because I don't know drdt. Well, if I don't want there to be a drdt, there better not be an r to start with. Because as soon as there's an r, when you take the derivative, there's going to be a drdt. So how do I get rid of r? Well, that's where I look at this relationship, and r might be 2 times the height, half a height, a third of the height, whatever. And this one, it's a third of the height. So then I'm plugging in, I squared it, and I get to this equation. So then I take the derivative, so v over dt, take the derivative over here, 3 times 127 is 1/9, reduce the power by 1, and then you took the derivative of an h, so multiply by the h dt. And then I forgot what they gave me, so dv dt is 9 pi over 4. I got the pi, I got h is 6, to solve this for dh dt. So I'm going to cancel out the pi's. And then I got 9/4 equals, well, 6 squared is 36. 1/9 of 36 is 4. And then if I divide both sides by 4, it'll become 9/16. And this is the change in the water level. So this is centimeters per second if I'm labeling on that. And it's positive. Why is it positive? Because we're going up. What do you got to that? I know I started the problem with you, but questions on that second part? Okay. Should I start the next one with you also? Or should I let you try it? What do you think? Well, we're just going to do more code ones. So do you want me to do another code one or set you free? Yeah.
With the units, I don't remember if you said, would it be cube or square?
It's just height, so it's just centimeters per second. Area would be centimeters cubed per second. Volume would be, I'm sorry, area would be squared per second. Volume would be cubed per second. I'm going to do number 3 with you. Whether you want me to or not. If you don't want me to, just start going and ignore me. How about that? Alright, so number 3. So, again, I see cone, and it's being filled with water. At what rate is water being poured into the cup? So this is a value of a cone question. We're pouring water into this cup, and the volume of that water is increasing. So I'm starting off going, okay, I know the volume of a cone. Hopefully now we know that. It's 1/3 pi r squared h. But looking ahead, I know that the water level is rising at a rate of 2/h. Okay. Let's start there. Can we make an equation or like what would I set equal to 2/h? The water level is rising. That's dh over dt equals 2/h, but what's h? 9. So can't I just say it's 2/9? See what I'm doing? So Ryan, what's that face? Yes or no? Okay. Okay. I know h is 9. And I'm looking for dv dt. Well, if you look at this list that I've made over here, there's not an r there, there's not a dr dt there. So I can't have an r involved in my process. Which means I need to get rid of the r that they gave me. They give you the way to do that every time by giving you the relationship of the actual cone. So what they're telling you here is that the height is 10 and the radius is 10. You can use that to make an equation. And in this case, what equation relates r and h? They're just equal. So I'm just going r equals h. R might be 2 times h, 3 times h, 1/3 of h, 1/4, whatever. But in this case, they're 10 and 10, so r equals h. So when I go back to my original equation, instead of putting an r there, what can I put? I can put an h. And now you finish it. So I did a little less for you this time, but still started. So you guys finish it from there. Unless there's questions I can answer right now, yeah.
For all these problems, it seems like they're always canceling out R. Is there a problem with that? People cancel out R.
The cone ones? No. All the cone ones are going to be pretty much the same process. But if it's like an area of a circle, you're going to have ours. That's different. Different ballgame. Yeah.
So when you plug in the h, would it just be h cubed then?
Yep. Well, so it's going to be 1/3 pi h squared h, which is the 1/3 pi h cubed. Yeah. So the last one was like 1/27, but that's because we had the 1/3 involved. They got squared also. They went into that. So the cone ones, it's always going to be the same thing. So I'm going through and showing you like why. I hope that helps you remember. But basically, if you see a cone one on the test, you know that there can't be an R involved, and so you have to do something to get rid of the R, which is going to be this extra step over here. So are there questions on how I got to this 1/3 pi h cubed? So then we're going to take the derivative, so dv over dt. 3 times 1/3 just cancels, so you just get pi h squared times dh dt. And then in this case, I'm looking for dv dt. H is 9. dh dt is 2 9ths. So we're just multiplying that out. So this 9 cancels with one of those. So this would be 18 pi. And this would be its volume, so centimeters cubed per whatever per second. What do we have that? Questions? Alright. Cross off number 9 and 12. If you didn't get through those, then that's fine. And so you're not responsible for them for your test. If we didn't go through them, I'm not going to hold you to them. So 9 and 12 you can cross off. Everything else on here you should know how to do. And then, so finish this packet for tomorrow so I can answer any questions on this packet. And then tomorrow I'll give you a review, practice test scenario thingy, so you know what to study.